So hi guys, today's video we're going to do the activity on chapter 7, which is the IP addressing, and all of these activity are we're going to do today. So let's find the first activity of this chapter. So here's the first activity, which is from page 7.1.1.5, activity binary to decimal conversion. So let's find out. So here's the instruction about this activity. So this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So here we can put our answer, the decimal value. So for us to do or to answer this activity, let's focus to the bit. So this is very easy because if you focus on the bit, you can see the 1 0 1 0 0 1 1 1. So you will add this this bit with a value of 1 to the, and the value of this will be this 128. This one is the 64, and this one 32, 16, 18, 4, 2, 1. So for us to answer the to get the decimal value rather, let's add this bit to each corresponding value. So the first one will be the 128 plus 32, then another value will be the 4, then 2 plus 1. So the decimal value of this bit will be 167. So let's try if it's correct. So let's check it. So that's correct. The decimal value you have to enter is correct. Please click new number to continue. So let's have another number. So for this one, you will add this bit with the value of 128 to this bit with the value of 2. So 128 plus 2 is equal to 130. So let's find out if it's correct. So correct. So that's the way how binary to decimal conversion activity. So let's find another activity for this chapter. So it is page 7.1.1.8, the activity which we decimal to binary conversion utility. So for this one, we will be put the bit opposite to the first activity. We have the decimal value, and the you will find the bit of this decimal value. So for us to do this, that's fine. So this will be 1 because 16, and this will be 1 again, and then the rest will be the 0. So why we come up to this bit? Because 16 plus 2 is equal to 18. That's what are the decimal value. So let's find out if it's correct or not. So as you can see, this is correct. These binary values you have entered for all positions are correct. So let's try another one. So 143. So for us to get the bit of this decimal value 143, let's add the now the position, which will be equal to the 143. Um, I think that's mm, Wait, I will compute it. 8, then 4, then 2 plus 1, so 143. So this will be a bit of 1, a bit of 0, a bit of 0 again, and this will be a bit of 0 again. Then the rest will be 1. Why would come up for this bit? Because this bit will be equal to the decimal value, which is 143. So 128 plus 8 plus 4 plus 2 plus 1 is equal to the value of decimal value 143. So let's check it out if it's correct or not. So as you want to see, it's correct. The binary values you have entered for all the positions are correct. Please click the unit. So this is done for, we are done for this activity, which is the decimal to binary conversion activity. So let's find out another activity for this chapter. Okay, so this is it. So for this activity, we have activity ending to determine the network address. So here's the instruction for this activity. Use the ending process to determine the network address. So for this activity, to come up with this to answer this activity, we will have focus on the host address in binary and subnet mass in binary. So all of the value, all of the one with this two, the same value or the same bit with equal to 1 will be 1, and the rest will be equal to 0. So for this example, you have 0 0 0 0 1 0 1 0, because this will be the same, so it equals to 1, this, and then 0 equal to 0, 1, and equal to 1. So for the second one, 1 0 1 1 0 0 1 1, and then for this one, 0 0 1, then 0. Then for this one, this will become 0. Then the network address for this one, let's compute it. If it's 10, this is 1 2 4 8, sorry, is equal to 10. Then this is 179, and this is 1 2 4 6, sorry, 1 2 4 8 16 64, and this will be 0. So let's check if it's correct or not. So we have incorrect value. So 1 2 4 8 16. So my mistake, this will be 32. So let's check it out if it's correct. So now the binary and decimal version of the network address are correct. Please click the new number below. So for doing this activity, you have focus on the subnet mask in binary and thus address in binary. So the rules of end process, this will be if the host address in binary and subnet binary are both have one value, then you will come up to the one, also one. So this this if host binary is 1, then this is 1, then you will come up to network address will be 1 again, will be 1 also. So because of that, they have different value, 0 and 1, they come up with 0. So always remember that if they have the same bit of 1, and this will be equal to 1 again. So we are We are done in doing the ANDing to determine the network address. So let's find another activity for this chapter. So, um, so this one. So here's the instruction for this activity. So click start to view destination IP address. Then next click the host, which is will receive a packet based on the address type, unicast, broadcast, or multicast. This is a time activity. So this activity will call the unicast, broadcast, or multicast. So for us to do this activity, we have a past mind to answer this because we have time remaining, which will be 10 seconds. So let's start. So the destination address, this will be, so this one and that only one. So yeah, you have successfully identified the transmission type. Why? Because 192.168.100.2. So let's this answer this one again. Mm, sorry, but let's try another one. So let's start. Mm, this one and this one. So this will be a broadcast. Okay, you have successfully identified the transmission type. So let's wait for the another one. So this one. So this is unicast. Okay, you have successfully identified the transmission type. Let's wait for the another one. So this 255 192.168. This one. Oh, sorry, but so okay, let's find another one. I'm not that fast. Okay, this one. Okay, now that's the end of this activity. You will find the destination MAC address for this activity, and then you will click this. You will identify if it's unicast, broadcast, or multicast. So remember, if unicast, there only one for the broadcast. This will be two, and for multi, uh, if broadcast for the world what you call malawakan wide spread of this activity and multicast for the one and two. So let's find another activity for this chapter, which is for this. So okay. So activity fast or lock. Internet Protocol version 4 or IPv4 address. So here's the instruction for this activity. Decide to pass or block each IP address depending on whether it is public, the internet, or private. Small local network. Click start to begin and click on either pass or block. So remember that the um, private small local network will start with 192.168.172 and 10. So let's start for this activity. So 192 block, this will be public, a public again, then block, oh sorry, but a pass again, this public, then block because that's private. So yeah, you have successfully identified public and private address. So remember that a private small local network are start with 192.168.172 and 10. So let's find another activity for this chapter. Um, okay, this is, so this activity which is public or private internet protocol version 4 address. So here's the instruction: drag each IP address to correct category, public or private. So here's the IP address. So as I said earlier ago, the public address will be start with 1.172, then this 192.168, a private network. This will be a public network, and then a public network again, a public network again. So a private network, and then this one private network because we have 172.16, and then a private network again because as I've said to the activity pass or lock, the private network start with 172.16, 192.168, and 10.55. So check it out. Let's check it out if it's correct or not. So as you can see, these are correct. So you have correctly identified all the IP addresses. So let's find, so we are done to do this activity. So let's find another one. Let's check it out. So here's the second activity, which is the activity IPv for issue and solution. So for this one, um, here's the instruction: drag the IPv4 and IPv6 term to the field next to the appropriate description. So the first term description will be 128-bit across. So this will be an IP version 6. 32-bit will be the IP version 4. Transport an IP path over IP network. This will be a tunneling, and then use use not 64 to convert in translation, and then the last one will be the dual stack. So we are done in answering this activity. So let's find out if it's correct or not. So let's check it. So as you can see, you have successfully matched the IPv4 and IPv6 terms to their description. So let's find another activity for this chapter. Okay. Okay. There is the next activity for this one. Here's the instruction of this activity, which called practicing IB Internet Protocol version 6 address representation. So here's the instruction: convert the IP version 6 addresses into a short, omit the leading zeros and compressed form. Use the number at the bottom of the page to continue this activity. So for this one, the omit leading zeros will be this one, 2001, and this will be a 0. Then disregard the 0 and type the DB8. Then for this one will be the 111. Then disregard again the another 0 because if you put the um if you put uh all this 0, you have come up to the wrong answer because, and then 0 again, this one is 0 again, and then as you can see, disregard the start 0 and you can start to the 200. So for this one, this one, so as you can see, these are correct. So because 201, this one 0, this one db8, this one 1, then double semicolon, and you disregard all this 0 because they you use this 0, and if you use 0 for this one, you have to disregard this one and you will come up to this one. So let's move on to the other activity, or let's try another one. So for this one, we have 213, then 0, then 1, 2, 3, 4, 5, 6, 7, 89, AB, CDEF, then 0, then 1. So for this one, to 13 colon 0, 1, 2, 3, then the value of 4, 5, 4, 5, 6, 7, then the CDEF, then disregard this 0 because you use 0 for the one, then double semicolon, then 1. And let's check it out if it's correct. Oh, so but we have this. So if it's correct, okay, maybe we can try to do this. Okay, what's to be the problem for this one? 13, 0, 1, 2, 3, 4, 5, 6, 89. Okay, we don't have the 89 EB. Sorry, I forgot to put 89 AB for this one. So let's check. So it's correct. So now that we have done to do this activity, let's find another one. So this activity, identify types of IV Internet Protocol version 6 addresses. So here's the instruction. Drag the IP version 6 address type to the most appropriate description. So the first description will be unique internet routable IP version 6 address, dynamic or static. This will be a global unicast. FE0 ETs semicolon. Um, link local. Then this will be a bit of 64 as you can see. Then this will be again a link local and used to communicate with other devices on the same IP. And this will be the global unicast. So let's find it out if it's correct or not. So okay, so maybe that's a global unicast. Then this is a bit 64. Then this will be a link local. So let's check it out. So you have successfully matched the IP version 6 address type under description. So let's find another one activity for this chapter. So okay, 7.3. Okay. Okay. So here's the summary of this chapter 7 IP addressing. So IP addresses are the hierarchical with network, subnetwork, and host version, and an IP address can represent a complete network, a specific host, or the broadcast address of the network. Understanding binary notation is important when determining if two hosts are in the same network. The bits within the network portion of the IP address must be identical for all devices that resides in the same network. So the subnet mask or prefix is used to determine the network portion of an IP address. So IP addresses can be assigned either to statically or dynamically. DHCP enables the automatic assign of addressing information such as IP address, subnet mask, default gateway, and other configuration information. So IPv4 hosts can communicate one of the three different ways: unicast, broadcast, or multicast. So also block of addresses that are used in the network that require limited or to no internet access are called private addresses. So the private IPv4 address blocks are 10.00 bit of 8, 172.16.00 bit of 12, and 192.168 with a bit of 16. So the depletion of IBP4 address space is the motivation factor for moving the IPv6 or Internet Protocol version 6. Each Internet Protocol version 6 address has 128 bits versus the 30 bits in the IPv4 address. So IPv6 does not use that dotted decimal subnet mask notation. The prefix length is used as to indicate the network version of an IPv6 address using the following format: IPv6 address prefix length. So these are the three types of IPv6 addresses: unicast, multicast, and unicast. An IPv6 linked local address enables a device to communicate with other IPv6 enabled device on the same link and only on that link subnet. Package with the source of destination linked local address cannot be routed beyond the link from which the packet originated. IPv6 linked local addresses are in the FEAT double semicolon with a bit of 10 range. So now guys that we have done in answering all the activities of the chapter 7, which is the IP addressing. So hopefully guys you are learning something about this activity. Then thank you for lending me some times of yours. So thank you guys for watching, and um, see you again for the next video that I will video.